Hello students, good morning students. Today our topic is Rydberg equation applications. Mains point of view and as well as NEET point of view, Rydberg equation important students. Mains as well as NEET point of view, applications. That means problems are important. This is the Bohr model based. This equation is based on the Bohr model, Bohr atomic model. What is the Rydberg equation? Nu bar is equal to 1 by lambda is equal to RH into Z square 1 by N1 square minus 1 by N2 square centimeter inverse or Hz. Here Z indicates atomic number. RH indicates Rydberg constant, that value is 1,09,677 centimeter inverse. 1 by RH value is 912 angstroms. This representation is important for problems point of view. 1 by RH value in angstroms. Here N1 indicates lower energy orbit, N2 indicates higher energy orbit. Here observe students, question number 44. What is given? The data. Which transition in the hydrogen spectrum would have the same wavelength as the Balmer type transition from n equal to 4 to n equal to 2 of helium plus spectrum? The question. 2023 mains examination question. You know that already Rydberg equation. Here in the question, what they mentioned in the sentence, same wavelength. Wavelength of hydrogen is equal to the wavelength of helium. They mentioned it like this. So by using this point, apply this this relation in this equation. 1 by lambda h is equal to RH. Hydrogen atomic number 1. So 1 square. 1 by N1 square minus 1 by N2 square. This is hydrogen equation. What about the helium equation, helium expression? 1 by lambda helium plus is equal to RH. Helium atomic number, you know that 2 square. 2 square. 1 by N1 value of helium, how much is given here? 2. N2 value is 4 is given. So 2 square minus 1 by 4 square. So this relation, by using this relation, this is equal to this one. That means RH 1 square 1 by N1 square minus 1 by N2 square is equal to RH 2 square 1 by 2 square minus 1 by 4 square. So RH get cancelled. RH cancelled. What is remaining in the left side? 1 by N1 square minus 1 by N2 square is remaining. Right side, what is remaining? 4 move to inside. Then that is converting into 1 by 1 square minus 4 here. 1 by 4 by 16 means 1 by 4. 1 by 4 means 2 square. Na? So 1 by 1 square minus 1 by 2 square. So what is the N1 value here? 1. What is the N2 value here? 2. N1 is equal to 1. N2 is equal to 2. In this transition, helium transition, what is given? N1 value 2. N2 value 4. This transition wavelength value is same simply. So without doing this calculation, one hint I am giving you. 2:4 na? 2:4. What is the simplest ratio? 1:2. That's it. 1:2. Here also 1:2. Same wavelength. Here students, observe the question number 45. What is the question number 45 is given? The shortest wavelength of hydrogen atom in Lyman series is lambda. The longest wavelength in Balmer series of helium plus is. The question is that. Shortest wavelength of hydrogen atom in Lyman series. Once observe that hydrogen spectrum once. What is the hydrogen spectrum? Already you know that. This is hydrogen spectrum. In the hydrogen spectrum, these are orbits. These are the spectral lines. In the hydrogen spectrum, different spectral lines we have. Lyman series, Balmer series, Paschen series, bracket series. You know that already, series of lines. In the every series, the Lyman series or Balmer series or Paschen. In the every series, the first line, this is the first line. The line comes from the infinite orbit. That is the last line. This is the last line. here this is the first line. This is the Lyman series. The question is based on the Lyman series. First line, energy gap is less. Energy gap is less means wavelength is more. Last line, energy gap is more, wavelength is less. The electron is coming from infinite orbit to n is equal to 1. That is shortest wavelength. Remember this. This is shortest wavelength. The electron is coming from here to here. This is wavelength is more. That is longest wavelength. Longest wavelength. So in the every series, the electron is coming from the infinite orbit. The wavelength is the shortest wavelength. In the every series, the electron is coming from the next higher orbit. That is the longest wavelength, students. So based on this point, observe the question number 45, students. Shortest wavelength of hydrogen atoms is asking. So 1 by lambda of hydrogen atom is equal to RH Z square 1 by N1 value in the shortest wavelength 1 square. N2 value is coming from where? Infinite square. This is shortest wavelength of the hydrogen atom. The question is given the longest wavelength of Balmer series of helium plus. Balmer series means this is the Balmer series. Balmer series first line is this one. Electron is coming from third orbit to second orbit, students. Remember this, Balmer series. So 1 by lambda helium plus is equal to RH Z square 1 by N1 square minus 1 by N2 square. In the Balmer series, asking helium. Helium atomic number, Z value 2. Balmer series N1 value 2. N2 value 3. So these values substitute here. So 1 by lambda helium plus is equal to RH. Z value 2 square. N1 value 2 square. N2 value 3 square. So this is considered as hydrogen, that is considered as first equation. This is considered as second equation. Now equation from 2 and 1. From equation 2 and 1, divisible 2 equation by 1. What is the cancellation here? RH cancelled. What is the remaining? Z square, hydrogen atomic number 1. No. So 1 by 1 square root minus 1 by infinite square root. Nothing is remaining here. Here nothing is remaining. What is remaining here? 2 square. 1 by 2 square minus 1 by 3 square. So helium, that is value is 1 by lambda helium plus into lambda of hydrogen by 1 is equal to, what is the value remaining? 2 square 1 by 1 square minus, how much is remaining? 4 by 9. So 9 minus 4 by 9, 5 by 9, students. So lambda h is equal to 5 by 9 by lambda helium plus is the answer. So asking lambda helium plus na. So lambda helium plus is equal to 9 by 5 lambda h. This is the option. So 9 by 5 lambda. Here this is the option. Next question, observe here, students. If wavelength of first line of Paschen series of hydrogen atom is 720 nanometers, then the wavelength of the second line of this series is how many nanometers? That is the question. What is the series is given? Paschen series is given. You know that already, students. Hydrogen spectrum. Here look at this. This is the hydrogen spectrum. In the hydrogen spectrum, first line is Lyman series. Second orbit is the Balmer series. Third orbit is the Paschen series. Paschen series starts from third orbit. So here electron is moving from fourth orbit to third orbit. That is the first line of the Balmer Paschen series. If electron is coming from n is equal to 5 to n is equal to 3, that is the second line of the Paschen series. So here first line in the Paschen series, first line n equal to 3 That means n1 value equal to 3, n2 value 4. Second line in the Parsons series, n1 value equal to 3, n2 value equal to 5. So Rydberg equation, you know that. What is the Rydberg equation? 1 by lambda is equal to RH z square 1 by n1 square minus 1 by n2 square. This is the Rydberg equation. In this Rydberg equation, substitute the values of these. So this is the first wavelength 1 by lambda 1. Value how much is given in the question? 720 nanometers are given. 720 nanometers. That is equal to RH z square is the 1. 3 square minus 4 square. This is the first line, first equation. This is considered as first equation. 1 by lambda 2, that is the second line, is equal to RH z square. N1 value here 3 square minus 1 by 5 square. This is considered as second equation. So now do that equation 1 by equation 2. Simply 1 by 720 nanometers into lambda 2 by 1 is equal to, what is cancellation here? RH cancelled, z square cancelled. What is remaining here? In this relation, what is remaining? 1 by 3 square means 1 by 9 minus 1 by 16. After simplifying 1 by 9 minus 1 by 16, 16 minus 9 by 9 into 16. So 7 by 9 into 16 is remaining. Here what is the remaining? 1 by 9 minus 1 by 25. 1 by 9 minus 1 by 25, that means 25 minus 9 by 9 into 25. So 16 by 9 into 25 is coming here, 7 by 9 into 16. So these values substituted here, 7 by 9 into 16 into 9 into 25 by 16. What are the common values here? 9 get cancelled. So what is remaining here? 7 into 25 by 16 into 16 is remaining. So here asking lambda 2 value. Second line wavelength is asking. So lambda 2 is equal to this value, move this side, into 720 nanometers. So after simplifying that value, how much value you are getting? That is the answer.